Life has full of wonders. Those wonders feeds our curiosity, and curiosity is the key to knowledge. Good day everyone, I am Cagbabanua from Group 1 and today we are going to talk about the science, matter, energy, and system. General process that scientists use for discovering and testing ideas. Scientists are curious, skeptical, and demand evidence. Scientists are skeptical of new data. During the peer review process, what do scientists publish? The methods they use, the result of their experiments, reasoning behind their hypothesis. Scientists use a dynamic, open-minded process to investigate questions. Here are the 5 steps. 1. Define a question to investigate. 2. Make predictions. 3. Gather data. 4. Analyze the data. 5. Draw conclusions. Let's talk about the first one. Define a question to investigate. As scientists conduct their research, they make observations and collect data. The observations and data often leads them to ask why something is the way it is. Scientists pursue their answers to these questions in order to continue their research. Once scientists have a good question to investigate, they begin to think the ways to answer it. Second, make predictions. Based on their research and observations, scientists will often come up with a hypothesis. A hypothesis is an impossible answer to a question. It is based on their own observations, existing theories, and information they gathered from other sources. Scientists use their hypothesis to make predictions. A testable statement that describes what they think the outcome of an investigation will be.
So number 3, gather data. Evidence is needed to test the prediction. There are several strategies for collecting evidence or data. Scientists can gather the data by observing the natural world, performing an experiment in a laboratory, or by running a model. Scientists decide what strategy to use, often combining strategies. Then they plan a procedure and gather their data. They make sure the procedure can be repeated so that other scientists can evaluate their findings. So there are ways for scientists to collect or gather data. Observing the natural world is a productive way because scientists can see for themselves what is actually happening and they can create explanations and details about it. An experiment in a laboratory. This common way of gathering data is mostly efficient and produces clear evidence and explanation for scientists when gathering data. And another way is running a model. This way, scientists would see the function or the way it moves. So procedures are an important part when gathering data. This makes sure that they know exactly what they're looking for, and also their findings can be reevaluated by other scientists for confirmation. Number 4 is analyze the data. Scientists organize their data in tables, graphs, or diagrams. If possible, they include relevant data from other sources. They look for patterns that show connections between important variables in the hypothesis they are testing. So, in analyzing data, scientists organize the data they have gathered to make their findings efficient and their work productive rather than not sorting them at all. So they also use outside data for more connections for that hypothesis they are testing. So number 5, draw conclusions. Based on whether or not their prediction came true, scientists can then decide whether the evidence clearly supports or does not support the hypothesis. If the results are not clear, then they must rethink their procedure. If the results are clear, then scientists can write up their findings and results to share with others. The conclusion they draw usually lead to new questions to pursue. So in drawing conclusions, scientists create conclusions of their findings. So when their predictions are wrong, then they use a different way of experimenting and start again. But when their results are correct, then they share that information with others. And first they create a conclusion about that specific experiment. Then they share that information with others. So the conclusion they draw can create more questions to follow up with their new findings. So that's
Scientists cannot prove or disprove anything absolutely. There are inherent uncertainties in measurements, observations, and models. Scientists use words such as overwhelming evidence to clarify probability or certainty. Being human, scientists are not free from bias, but peer review helps to reduce personal bias. In my own words, just like us, scientists are also human beings that has flaws and errors. Although, even if a theory is not proven, scientists provide overwhelming evidence that increases the probability and enhances the certainty. Let's go to the next slide. B. Matter and what happens when it undergoes change. But first of all, let us know what is matter. Matter. Matter is the basic structural component of all things that have mass and volume. It is anything that occupies space and has mass. All physical objects are composed of matter, and an easily observed property of matter is its state or phase. The classical states of matter are solid, liquid, and gas. Several other states, including plasma and Bose-Einstein condensate, do exist, but it is the classical states that can transition directly into any of the other classical states. For example, this phone is also considered as matter. Why? For this reason, it occupies space, it has mass, and it is composed of atoms. So, moving forward, as I have discussed, matter is composed of atoms. Now, what is an atom? So, an atom is the basic building block of matter. And it is also the smallest building block of matter that an element can have that will still retain its chemical properties. Each atom has 3 subatomic particles. It is known as the protons, the electrons, and the neutrons. Both subatomic particles are distinguished between their electric charges. So the protons have a positive charge, the electrons have a negative electric charge, and neutrons have no electric charge. Furthermore, each atom has a small central nucleus that contains its protons and neutrons. It also has its atomic number. Atomic number is the number of protons in an atom's nucleus. It also has its mass number. The mass number is the total number of neutrons and protons in an atom's nucleus. And lastly, isotopes of an element have the same atomic number, but a different mass number. It has the same number of protons, but a different number of neutrons.
Molecules and ions are the building block of a matter. So molecules, 2 or more atoms of either the same or different elements are held together by chemical bonds. So it is the group of atoms that are bound together to represent the smallest fundamental unit of a chemical bond, or chemical compound rather. So for example of a molecules is the water, the combination of hydrogen and oxygen. And water, we all know that water is very essential to human life, because if there is no water, there is no possible life on earth as well. So ion, a group of atoms with 1 or more net positive or negative charges rather. So if an atom gains negative charges, there will be a negative ion will be formed. And in vice versa, when the atom gain a positive charges, there will be a positive ion formed. So, muna siya. For example, an ice cube left on a bench at room temperature quickly changes to liquid water, whereas a jet of steam from the spot of a boiling kettle changes to liquid water when directed into a cold surface. Matter undergoes physical, chemical, and nuclear changes. What happens when something will undergo changes, whether it's physical, chemical, or nuclear? So let's talk about physical change. Physical change is a change that involves only a change in its physical state of matter. Its chemical properties remain the same. For example, o pag gahi kag tubig, musumoy mo siya ice, di ba? So, pag melt na siyang ice, mabalik na siya sa form of water. Kaya ang physical change is reversible. So, mabalik siya sa original form. Physical changes involves moving molecules around but not changing them. Some types of physical changes include, so there are 4 types, which are changes of state, separation of a mixture, physical deformation, and making solutions. So in changing of states, for example, solid to liquid, or in vice versa, or even in changing it into gas. Freezing, boiling, or bending, for example, is melting an ice. So, freeze man siya sa una. So, pag ma-melt na siya, mabalik na siya sa water, sa original form. Separation of a mixture, evaporation, distillation, or filtration. Evaporation, for example, na mo-boil ka, naman na mo evaporate na mga murag bubbles ka ng kaysa tubig na siya. So, physical deformation, crushing a can, melting an ice, breaking a glass. So, ang physical properties niya is mausob, like breaking glass mo scatter abi siya into pieces. Mugang may siya, pero pag ibalik na mo siya, mubalik na siya sa original form. So, ang chemical properties niya, dili siya mausob. So, on making solutions, ang example sa making solution is, for example, water, butangan mo siya og sugar. Ang taste sa water, mausob siya, like mutamis siya, pero ang chemical properties sa water, dili siya mausob. It will remain as a water. So, mauna siyang upat, changes of state, separation of a mixture, physical deformation, and making solutions.
Melting. Melting is an example of a physical change. A physical change is a change to a sample of matter in which some properties of the material change, but the identity of the matter does not. When liquid water is heated, it changes to water vapor. However, even though the physical properties have changed, the molecules are exactly the same as before. So basically, melting is a change of solid into a liquid. When heat is applied, kinahanglan natog heat in order to melt something. Or heragod anang magmelt ang kandila, we need fire in order to melt it. And fire produces heat, and heat makes the candle melt, and that is melting. Chemical change. A chemical change is a change that involves a change in the chemical composition of matter. A new substance is formed. In a chemical change, new chemical and physical properties of the substance are formed. In a chemical change, the chemicals and physical properties of the substance formed will be different from the original substance. And here are some examples of physical change: burning wood, souring milk, mixing acid and base, digesting food, cooking egg, heating sugar to form caramel, baking a cake, rusting of iron, and that's all. Here are some observations that helps to indicate chemical change. It includes the first one, temperature changes. It's either temperature increases or decreases, and the next is light is given off. The third one is unexpected color change. A substance with a different color is made rather than just mixing the original colors together. And the next one is bubbles are formed, but the substance is not boiling. And you made the substance that is a gas at the temperature of the beginning materials instead of a liquid. And next is different smells or taste. Do not taste your chemistry experiments. And the next is A solid forms if two clear liquids are mixed. Look for floaties, technically called a precipitate.
Nuclear change is a distinct from chemical change in that elements change. Chemical change is all about the electrons. In chemical change, the nuclei are conserved and simply change how they are bounded together. While in the nuclear change, it is all about the nuclei. In nuclear change, the elements can change from one to another. Nuclei can break apart to form smaller elements. Nuclear change can fuse together to make heavier elements. So in general, chemical change and nuclear change is not the same because chemical change is about electrons while nuclear change is about nuclei. Nuclear change is a process such as fission, fusion, or radioactive decay in which the structure of an atomic nucleus is altered through release of energy or mass or by being broken apart. The number of nuclei in the element atom changes resulting in release of energy. Main types of nuclear changes that matter can undergo. First is the radioactive decay. Radioactive decay, or also known as nuclear decay, radioactivity, radioactive disintegration, or nuclear disintegration, is the process by which an unstable atomic nucleus loses energy by radiation. Second, nuclear fission. Nuclear fission is a reaction in which the nucleus of an atom splits into two or more smaller nuclei. Last, nuclear fusion. Nuclear fusion reaction powers the sun and other stars. In a fusion reaction, two light nuclei merge to form a single heavier nucleus.